HPCC Systems already has the ECL machine learning library where they have a host of different analytic packages to be able to get significance out of find things within their data. And one thing that has been recently implemented by John Holt is the parallel block basic linear algebra subprograms. So in this, what it does is when you're working with matrices, if I had a 4x4 matrix and multiplying it by 4x1, the result would be a 4x1. What PB-BLAS or P-BLAS, depending on who you ask, it breaks these matrices down. It partitions these matrices. For example, we can have two 2x3s, two 2x1s, and these 2x3s are multiplied to these 3x1s, and you are pretty much partitioning them and multiplying these partitions together to produce output, and then you're bringing those back together to produce the 4x1 matrices. And one of the reasons that this needed to be done is that there was already an implementation of logistic regression in the ECL machine learning library, but it was slower than what they would like to see. So I was tasked to re-implement this and leverage this PB-BLAS. And some of the results that I had from this, and these results are from the Higgs Boston project. It's a high energy physics project where they're trying to classify some things, and I partition these into 1,000 data set, 10,000, and 100,000. And the normal implementation previously for 1,000 instances trying to classify took about 15 minutes, and these had 28 different attributes per record. And for 1,000, it took about 15. But when you look at 100,000, it took over half an hour. After I finished the implementation, we were down to roughly about 6 minutes for each one of those. And this, I'm trying to save space, so this is a hard-coded mapping. What I did on top of that was implemented a auto block vector mapping. So whenever you wanted to use the PB-BLAS, you didn't have to worry about how you wanted to break down these matrices. So this module will be able to take the number of the size of your cluster and the size of your data set and actually scale that down and break it down into partitions that are compatible. And this is another experiment that I did with some Elsevier data that was available to me, and this is just for 100. Oops. This is just for 100. And what you can see with the auto mapping, we went from about 20 minutes to again around 6 minutes. But then if we scale it up and look at a larger number of instances, for 1,000 instances, using the non-PB-BLAS took about 6 hours, I'm sorry. So it took a very long time. And then with the PB-BLAS implementation, using the auto map feature, we actually got it under an hour. Currently, logistic regression and its supporting functions with the auto block vector mapping, they've been documented and merged into the ECL GitHub repository. I also implemented the element-wise multiplication for PB-BLAS, and there's also test functions available for the auto block vector mapping. So then, if you didn't want to actually go through the process of having your ECL code come up with the partitions each and every time, you can plug your numbers into this function, and it'll provide it, and then you can actually hard code it yourself. And there's also some logistic regression sample code. And currently, I'm working on K-means implementation that utilizes PB-BLAS as well.